Hi, this is Dr. Herndon. In today's video, I will be talking about drug solutions. It's important for technicians to have a basic understanding of solutions and concentrations, as it is often the technicians who are responsible for making up various mixtures of drugs or disinfectants. You should be able to recognize the three ways that solutions are expressed, and you should be able to calculate volumes of drug mixtures. Solutions can be expressed in various different ways, and the common ways that we often see them is in number 1, a parts ratio, number 2, a percent concentration, and number 3, either a weight per volume, volume per volume, or weight per volume notation. This second part down here of the learning objective, calculate volumes of drug mixtures, it'll often be up to you to figure out how much of the drug and how much of the diluent you need to add together in order to make up a particular concentration of solution. Let's review solutions. A solution is a liquid mixture in which the minor component, or the solute, is uniformly distributed in the major component, or the solvent, which is in this case a liquid. The concentration of this solution, or the strength of the solution, is the amount of dissolved solute. If we were to add more solute, we're going to increase the concentration of this mixture. Most oftentimes we use what's called saturated solutions when we're looking at drug mixtures or IV fluids. You can see this 1% lidocaine solution is a clear solution. It's saturated. It's got the maximum amount of solute in it that it can hold. Down here, this is a suspension, but this is a solution in which the solutes are very large particles, and they actually settle out so that we have to shake a suspension before we use it to evenly distribute the active ingredient within the solution. Now let's look at the first of 3 ways a solution may be expressed. A parts ratio gives no reference units of measurement. It is a relationship of a solute, in this case the 1, to the total amount of the solution, in this case a 32. So in this example, the 1 is equal to the amount of solute in the solution, and the 32 is equal to the total amount of solution. Parts per million down here is another type of parts ratio. 1 part per million is the same thing as saying there's 1 milligram of solute in a kilogram or of a liter of solution. So that means there's 1 milligram of solute in a million parts. So there are a million milligrams in 1 kilogram. By the same token, 1 part per million would mean that 1 micrograms of solute is in 1 gram or 1 milliliter of solution. We can convert a ratio concentration, such as a 1:32 dilution, to a percent concentration. Percent concentration, as we will see, is equal to parts out of 100 parts total. So we can set it up like a ratio right here. 1:32 equals how many are X parts out of 100. Solving for X, 32X equals 100. X equals 3.1%. Let's try a parts ratio example. Quatricide is a common disinfectant which comes in a concentrated form. It needs to be prepared at a 1:64 dilution before use. How many ounces of quatricide should be mixed per gallon of water? So let's say you're asked to make up 1 gallon of solution. You want to know how much to add. Well, the first thing we can do is convert the 1:64 ratio to a fraction here so that we can do a ratio and solve for the unknown. So we want to know how many ounces we're going to add per gallon of water. Well, the first thing we need to do here is get our units the same. So if we're going to try to figure out how many ounces we need, we better convert gallons to ounces. Now, you can do this on your own. You can do it on a converter app. You can look it up on the conversion table. I've done it for us here. 1:64 equals X ounces. 1 gallon is equivalent to 128 ounces. So now we're merely solving for X, and X equals 2 ounces of quatricide added to 1 gallon of water. Let's look at a second way in which a solution may be expressed as a percent concentration. A percent concentration refers to the parts of solute per 100 parts of the solution. So if we're looking at a percent solution on a weight to volume basis, this means that in a percent solution, there are X number of grams of solute and 100 mils of solution. If a 5% solution has 5 grams of solute per 100 mils of solution. The third way that we commonly express concentrations of solution is on a weight per volume basis, such as in mgs per mil. If we want to convert a percent concentration to a weight per volume concentration, such as mgs per mil, there's an easy way to do it. We can simply multiply the percentage times 10. So in this example, percent solution 5 times 10 gives us 50, and our answer is going to be mgs per mil. This is something that you probably should memorize. Conversely, if we want to convert the other way from mgs per mil back to the percent, all we have to do is divide the concentration in mgs per mil times 10. So here we have our 50 mg per mil solution, divide by 10, that gives us 5, and we're back to percent. Remember I said that if you have a percent solution and you want to convert to mgs per mil, you're going to multiply the percent solution times 10 to get your answer in mgs per mil. So as another example, let's say we have something that's just, let's say 73%, and we want to know how many mgs per mil that is. Easy to do, multiply times 10, that's 730 mgs per mil. Remember that if we're looking at something that's 73%, that means there are 73 grams per 100 mils. Now if we were to convert grams per 100 mils to mgs per mil, well, the first thing we'll do is convert grams to milligrams. So we're going to multiply 73 times 1,000. That equals 73,000 divided by 100. We're going to cancel to the zeros. This equals 730, and our answer is going to be milligrams per mil. Okay, so let's do another example. Now we're going to look at, again, how to convert a solution that's in mgs per mil to percentage. And remember, for this, you can simply divide the number of mgs per mil times 10. So if we were to do an example, let's say we have a 20 mg per mil solution, and we want to know what percentage of a solution this is, we can simply divide the number by 10. 20 divided by 10 equals 2, and this is our percent right here. If we wanted to do this out the long way, which is perfectly acceptable, I'm going to write it out and just show you. We have our 20 mg per mil solution. Now, if you go back and remember that the number of grams of a solution over 100 mils gives you the percent of a solution. What we need to do is get this 20 mg per mil units right here to grams per 100 mils. So really that's just a simple conversion. So the first thing I'm going to do is convert mgs to grams by using my conversion right here. 1 gram equals 1,000 milligrams. Milligrams cancels. 20 divided by 1,000 equals 0.02, and our units are going to be in grams per mils. Now we still need to get from grams to mils to grams per 100 mils. So what I'm going to do here is multiply times 100 over 100. 0.02 times 100 gives you 2 grams. 100 times basically 1 down here gives you 100 mils. This looks very similar to this one on top, right? Grams per 100 mils. 2 grams per 100 mils is a 2% solution. Now, when you are making up a solution from a concentrated stock solution, it's important to have an easy formula that you can use for your calculation. This formula is used when you are changing a concentration of a solution. Let's look at this. V1 times C1 equals V2 times C2. Now, what you need to know is what the V's and what the C's mean. Let's say here that V1 and C1 over on the left is the amount of solution that you have and the concentration of solution that you have. Over on the right here, V2 and C2 are the amount and concentration of your final solution, or what you want to make, or what you need. Let's do an example to make this much more easy to understand. For example, if you have to prepare 100 mils of a 5% dextrose solution, and you have a 50% dextrose solution, that's your stock solution, and you also have sterile water to use to dilute it out. So what you have is V1, which you don't know how much that is yet, but you do know your C1 is 50%. What you need for V2 and C2 is 100. You need 100 mils at 5%. So now what we're going to do is plug these in, and you can see where your unknown is here. Your unknown is the volume of your stock solution that you need to take out of that vial to mix with sterile water. So we're going to plug in the numbers here. V1 is our unknown. C1 is 50%. You don't have to change that percent as long as you use the same units on either side. So I'm going to use percent on both sides. V2 is 100 mils. And C2 is 5%. So now we're going to solve for V1. 100 mils times 5 divided by 50. I already canceled out the percentages there. V1 equals 100 times 5, which is 500, divided by 50, which equals 10, and our units is in mils. So now I know that I'm going to have to take out 10 mils of my 50% solution in order to make my final solution here. How much sterile water am I going to use to dilute it with? Am I going to add it to 100 mils? No, because that's what I want to end up with. So I'm going to have to subtract 100 mils minus 10 mils equals 90 mils. So what I'm going to do is I'm going to take 10 mils of my 50% dextrose solution, add 90 mils of my diluent, and then I'm going to end up with my final solution, which is 100 mils, and this is going to be a 5% solution that I've made. Okay, I now have an example for you to try. Go ahead and pause the video and try this problem, and then when you come back, I will have the answer for you. Okay, I've written out the formula. V1 is your unknown. This is how much of the 100 mg per mil solution you are going to take out of that bottle in order to make your 5 mils of 20 mg per mil solution. The concentration of your solution, your stock solution, is 100 mg per mil. V2 over here, this is what you want to make. Your volume is 5 mils and the concentration is 20 mg per mil. Notice I didn't write the units after the 100 and the 20. They're both the same. As long as they're the same, you don't have to write them out. You don't have to cancel or convert anything. Solving for your unknown, which is V1, this comes out to 1 mil. So what you're going to do, you're going to be taking 1 mil out of this bottle here of the 100 mg per mil solution. You're going to be putting it in this syringe, but that's only 1 mil. You want to end up with 5 mils total. So you know that 5 minus 1 equals 4 mils. So where are you going to make up that 4 mils? With your sterile water. So you're going to be taking a mil of the concentrated 100 mg per mil xylazine solution, adding it to 4 mils of your sterile water, and then this will give you your final volume and concentration of solution. All right, now that you are great at working out your solution problems, go ahead and do quiz number 3 on Canvas. There's a few solution problems on there for you to try, and we have one more calculation video to watch and one more calculations quiz to take as well. Thanks.